Plains, we pay respect to their beliefs, cultural heritage, and continuing significance to the land. Today, we're very excited to be here together and watch the reveal of the Ultimate Goal Challenge. But stick around because we have some awesome tricks coming up for the challenge.
That's right. We'll be looking at basic design choices, the engineering notebook, robot control and programming, where to get help, and information on what the upcoming season will look like with the current COVID-19 landscape, with remote and traditional events.
All of this will be presented by some of the great teams we have joining us live today. They include the Paladins of St. Paul's, FTC 18003. We're also happy to be joined by the Murray Bridge Bunyips, that is FTC 15215.
The Trinity Buccaneers 1027. The Banksia Bots 15 to 16.
And the Robo-Roos 15 to 10. And without further ado, we would like to get straight into the game reveal of the Ultimate Goal.
For centuries, sports have played an integral part of our culture. Moving, collaborating, competing, celebrating. We rally around our athletes, lift them up and admire their awe-inspiring moments and stories that give us hope. History has shown societies evolving through time, and so too have sports and the way we play and move together. And now the nature of traditional sports is shifting, and we have the power to be forces for change and redefine the game. Our sports are no longer rooted solely in physical prowess. We must use our minds, our creativity, imagination, and critical thinking as much as we use our muscles. No matter whether our talents lie on the court, in the lab, or with a controller in hand, there's an athlete inside each and every one of us. It's time for us to revolutionize the way we play and move. It's time to be game changers. In Ultimate Goal presented by Qualcomm, you and your team will experience the passion that drives us forward as athletes. With the clock counting down, we revel in the big plays and vital scores, and the lessons we learn when we fail and work with our teammates to recover. Each time our team steps up to a new challenge, we establish bolder goals, fueling our ambitions to work together, enhance our skills, and transcend all boundaries. No matter the outcome, we'll stand up in the face of competition, pushing each other to do better, work harder, and exceed our team and personal potentials. Because together, you are teammates at the top of your game to score, win, and leave a legacy that lasts. Time to play Ultimate Goal. Welcome to the first Tech Challenge 2020-2021 season game, Ultimate Goal, presented by Qualcomm. Part of the first Game Changer season, powered by Star Wars Force for Change. A team consists of up to 2 driver operators, a coach, a human player, and a robot. The robot must be built from materials specified in the game manual and fit within an 18-inch sizing tool, but may expand after the match begins. Each match is played with 4 randomly selected teams, 2 per alliance. Each alliance is allowed only 1 human player. Your opponents for one match may be your partners for another. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. 5 unique navigation images are located around the field perimeter. At one end are 2 tower goals, each containing 3 alliance-specific goals with return racks. Between the two tower goals are 3 red and 3 blue power shot targets. There are 2 red and 2 blue taped start lines, and 3 red and 3 blue target zone goals. Red and blue tape squares indicate starter stack locations, and a white launch line divides the field. Outside of the field walls are the 2 alliance stations and 2 human player stations. The primary game element is a ring, approximately 5 inches in diameter and 3/4 of an inch thick. A match is played with 20 rings. There are 2 red and 2 blue wobble goals. These can have rings scored onto them and can be moved for additional scoring. Before each match, teams place their robots on the field, touching the front wall and over one of their alliance's starting lines. Each robot must be touching or be in possession of a wobble goal. A robot may possess or touch up to 3 rings. After the robots are in position, field personnel will randomize the starter stacks into one of 3 configurations. This determines which target zone goal is active in the autonomous period. 0 or 4 rings correspond to target zone goals A, B, or C, respectively. Unused rings are stored in the human player stations to be deployed to the field at the start of the driver-controlled period. The players and field are ready. Each match begins with a 30-second autonomous period. There are a number of ways for teams to score using only pre-programmed sensor inputs. Delivering a wobble goal to the correct target zone earns the Alliance 15 points. A robot parked over the launch line earns 5 points. Each ring launched or placed into the low goal earns 3 points. A ring launched into the mid goal earns 6 points, and launching into the high goal earns 12 points. Robots earn 15 points for each power shot target knocked down. Robots must be completely within the launch rings into the mid goal or power shot targets. The autonomous period is the ultimate driver-controlled period. During the driver-controlled period, human players are expected to return rings to the playing field, as well as reset power shot targets. Each ring launched or placed into the low goal earns 2 points. A ring launched into the mid goal earns 4 points. However, rings launched into the opposing alliance's goal earn points for their alliance. A ring launched into the high goal earns 6 points. The last 30 seconds of the driver-controlled period is the end game. During this time, robots may continue scoring rings, but there are also ways to earn bonus points. Each knocked down power shot target earns 15 points. Returning a wobble goal to the start line earns 5 points. Each ring fully supported by the wobble goal earns 5 points. If a robot lifts a wobble goal over the front wall into the drop zone, its alliance earns 20 points. There are many ways to score in Ultimate Goal, but there are also rules that, if not followed, will deduct points from your alliance. For example, a robot may not block another for an extended period. A robot may not possess more than 3 rings at a time. A robot may not launch rings over the side or front perimeter walls. A robot may not intentionally tip another robot at any time. This has been a brief summary of the Ultimate Goal game. For complete rules, please read the entire and check the Q&A forum. For more information on our remote season, including gameplay and field requirements, please visit our game and season webpage for the full library of remote event documentation. And always remember the rule of First Tech Challenge: gracious professionalism. Good luck, teams, and have a great season.
I'm KJ and I'm the captain of the Student Robotics Club of South Australia, and we're here to chat about what people's thoughts are about the competition. So what do you think, Caleb?
Look, KJ, I think Ultimate Goal is absolutely thrilling, and I think probably the thing for me that is like just really awesome about the challenge is there are so many ways that you can get points. It's not like, for instance, we had the little hoop objects. It's not like, for instance, oh, okay, take a hoop, throw it in, there you go, there's a point. But there's so many different ways you can do something. Do you want to go for the higher goal? Do you want to go for a medium goal, lower goal? And then that means, you know, how we design our robots. What sort of coding do we want to do? I just think it's such an open and broad challenge, and I think it's absolutely exciting.
Yeah, it's really interesting because every different thing comes with more points, less points, but more risk or less risk. It's all about reliability in these sorts of games. So what do
exactly
the next people think? Oh, what do you think?
It seems pretty cool. With most other games that I've seen, you can very consistently just pick up an object, move it somewhere, and know where it's going. But in this one, you have to throw stuff, and that may not go how we're expecting.
Yeah, I think I agree. It's the element of this one is tossing things, which is something that's a bit different for FTC since I've done it, and I think that's a bit dangerous, but I think it could turn out well. I think it's also interesting that for the target goals, it goes like red, blue, red. So if you're not accurate, you can also score points for other teams. That'll be interesting to see how people deal with that.
Yeah, it's a lot of risk management, especially as he said. If you miss, you're gonna probably screw your team up a little bit.
Yeah. Awesome. Yeah, we think it's going to be a great game.
Oh, no doubt at all.
Yeah. So even with all the different remote and traditional versions. So I think that's what we want to talk about now, a couple of differences between remote and traditional.
Well, I mean, now that we've seen a video sort of describing what we need to do, maybe now we might take it down and have a bit of a summary of the key part of it.
Yeah, so based on what we saw, the autonomous period, there's a lot of stuff about manipulating the wobble goal and seeing where to go with that based off of how many rings are placed in the randomization. So the randomization is something that we need to think about if we're doing it remote. I'd recommend rules for that one, but based on the rules, it's basically you just set it up based on what you're told to do by the competitions. And it's an interesting thing to talk about with the rules. There's quite a lot of differences between the traditional rules and the remote rules.
Definitely.
So there are actually 6 rules in the traditional game that aren't even in the remote game.
And I suppose that would be rules about robot-on-robot interaction, because obviously, remote game, you might not have a robot in the field that there is to consider.
Yeah, exactly. So rule G3, G28, G30, GS8, GS10, and GS11 are not in the remote rules whatsoever. They're just in the traditional rules. So that'll be interesting to see how that plays out.
The other thing that I think we need to keep in mind with first challenges is we have the game manual right here. Perfect. But first likes to make amendments to the rules as we continue. So I think it's very important as a team to be flexible, have sort of different ideas of how to do things, because people might think of one way of doing things, put so much time, engineering and programming effort into that, but then rule change comes along and that's no longer a viable option. So I think probably the most important thing is, like we said earlier, there's so many ways you can attempt this challenge. Keep all your different options in mind, write them all down, so it's easy to sort of shift between your different ways of thinking.
Yeah, and if you're unsure about something, ask the Q&A. That's a great way to get reliable information, and make sure that you're keeping up with checking the rule revisions, because you never know. And if you're going to try and cheat the game, they're going to change the rules so that you can't cheat the game. That's just how it is in first. And remember to always be gracious professionals. Woo! And now we're going to start talking about the strategy. So we've got a few members from Team Roboroos to have a chat about what they're thinking and what sort of strategy it's going to look like.
So thanks, I'm Jack, this is Derek, and this is Bianca, and so we're here to basically talk about some recommendations for the teams for robot strategy.
So for this presentation, we have split the different teams into three different types of teams that we're going to be talking about. Rookie teams who've had no experience with FTC. Some teams that have had some limited experience, perhaps this is their second or third season of FTC, as well as quite experienced teams that have been doing FTC for quite a while.
There are 4 main unique things the robot can do this season: pick up rings, drop off rings, shoot rings, and move the wobble goal.
So first of all, we're just going to go through the 3 levels, what we have broken down into the different teams, as Derek said. So first of all, our recommendations for rookie teams. So one of the main strategies would be to go for, we recommend to go for dumping into the low goal. This way you can earn up to 14 points in order if you dump 3 rings into the low goal and park on the,
Launch line.
Launch line.
So yeah, so this is a strategy that's adopted by most rookie teams during the first season in both FTC and FRC, and it can prove to be quite effective.
Yep, and then throughout the tele-op period, again, dumping into the low wall, into the low goal, will earn you points that way. Another point that you could use in the end game would be to push the wobble goal around. You could use this to actually line it onto the starting line to earn you 5 points, I believe. Yep, awesome. So some experience. Yep.
So for teams with some experience, the main strategy we'd recommend would be to be able to score goals in 2 different heights. Preferably which is middle goal, as it is the same height as the power shot, which is also a consideration to take into account, as if all 3 poles are knocked over during autonomous and later during endgame, it nets to a total of 90 points, possibly one of the best missions to complete in this season.
Yep, so then at the end game, we're also recommending for teams with some experience to have good manipulation of the wobble goal and be able to potentially dump it into the dump area, I think it's called. Awesome, so now our recommendations for best teams. So really abusing power shots will definitely score and rack up points very quickly, while focusing around the ability to not only be able to score in high goals but also in middle goals to allow yourself to get out of the way of your alliance member. And also for our best teams, we recommend that if it's possible to move not only your wobble goal but also your alliance partners, because then that'll actually make you a bit more, I guess, popular and also be worthwhile.
Another strategy that would probably work well for a team with a lot of experience would be to plan out several different autonomous runs, as well as having say like a visual system to detect which target the wobble goal need to be put in during autonomous, so then the robot can make the decision on its own.
Cool. And also another recommendation that we wanted to make, basically for all teams, is very much the necessity to be able to pick up rings from the floor, because unlike season spec, you could actually get the game piece deposited into the robot. This year you could see that you actually have to pick up from the floor, although that's not an actual rule. Awesome.
Okay, so during a match, the different skill levels of the robots on the same side would probably be at different skill levels. So, for example, during tele-op, when going for scoring goals, the skill sets of the robot will be different, so they will be able to take different heights for the goals. So we can here we can go through a few different combinations.
Yep. So this kind of setting it out this way allows you to not only effectively, because on the video you can see that the middle goal is actually on the other goal tower. If you have your blue team, it will be on the left, so you have your high goal and your low goal, whereas the middle goal is actually on the right tower. And this would allow you for a rookie robot to dump balls to dump rings into the left tower or the low goal, and whilst a better robot could shoot into the middle. And it's all about efficiency and being able to get as many rings into the towers as possible.
So this means that communication with your alliance partner before the match is also key to a successful run. I think that's about it. Thank you.
Thanks.
Good work to the Robo-Roos. Now we're going to have some basic design train. No, needs to be up here. Needs to be over here. We're going to have some basic design train designs with Jeff.
Hello everybody, I'm Jeff and I'm from the Robo-Roos. And who wants to build a basic robot? Well, it's going to be the inexperienced teams and the teams that are on small budgets that we're building basic robots. First Tech Challenge Resources Library, you'll find a link to robot building resources. And that'll take you to two sets, one for Tetrix and one for the Rev Starter Kit. There's a part one which builds a robot very similar to that. It's no good for matches because it's all exposed, phones will get smashed and there's not much room for anything to go on it. But it's a good one to program and to learn to drive. So that's part one. Each year there's a part two, and that's a game-specific robot. So we've got a game-specific robot for last year, which is that one. This was for Skystone, and in part two, you do this a bit of part one, and you're studying stuff. There's an arm and an arm station, which get it going the right way, and it was able to pick up stones and bring back, but it was too high to go under the bar, so you had to bring them down low. It worked quite well, but then we looked at the game and thought, how else can we earn points besides just lifting stones? In the game, there was an opportunity to carry a capping stone so that you could put it on your skyscraper when you're finished. So we decided to do that, and there was also quite a few points for having a tray grabber for the foundation. So we put a servo on the front with a grabber that was going up and down. When we were going to put that grabber in, that meant we had to bring the arm back a bit to make room so that it was going to fit inside the 18-inch tube to start with. So it's a modified part two, but the crux of it was given in the part two system. So to make room, we made a little vertical component so that we could put the battery in, stand it up. Takes up a lot less room when it's standing up than laying down. We put a floor in it, a little piece of plywood, cheap and strong and easy to use. We had a position then we could put the phone, the robot controller phone, in a protected position. And when you look at the manuals, you'll see that you have to put your robot number and the warning signs. So they've got to be on, and you've got to be able to have your alliance marker on. And by having signs, you've got some protection from other robots accidentally banging into you. Also, you can cut it out and set the power button inside a bit, so if a robot comes up to hit it, it's not going to turn it on or off, so you're protecting that. Now, yeah, this is last year's robot, but I've had a quick look at this year's robot, and I reckon if you spread those, you're going to be able to pick up the rings, you'll be able to come back here, instead of having a capping stone, you'll be able to make a little holding bay here for the rings, have a little platform that rises, put a servo motor on it and knock them into the low goal. So basic robots can store that. They'll be able to pick up the rings, they'll be able to put them on the wobble goal, they'll be able to lift the wobble goal and put it over the side. Now that's just been a quick analysis of the game and this robot, and I'm sure that the new part 2, which will be coming out in the next week or so, will allow itself to play the game well, and you'll be able to make some modifications for it. Now, just to show you that this robot, which didn't compete last year, it was a demonstration robot that we used in school workshops, so that's why it's got a wrong number on the front. We've got a short film here to show Joey scoring points as it did in Skystone, and you can see that it did pretty well there. Got the video, please?
This first robot is a basic RevBot Part 1. Joey is a modified Rev Basic Bot Part 2 for Skystone. In the 30-second autonomous period, it can move the foundation into the building site. In the 2-minute tele-op, it can build a 2-story skyscraper and place a capping stone. Joey can then position and park in the building site. It's a simple, reliable robot that has been modified to better grip the stones and to be able to grip and move the building foundation. Basic bot guides in the FTC Resources Library are a great help to rookie and inexperienced teams. Joey was built from a Rev starter kit.
Hello, I'm Sue O'Malley, coach of the Paladins of St. Paul's, and with me I have
Caleb.
Rowan.
Bradley.
Lachlan.
And Lachlan is from Bankshire, so he's come along with his super robot to show us. We're here to talk to you about how you go about choosing a drivetrain for the specific game, because every game has a different requirement. And so the first thing we did as a team was break down the requirements of the game. And we came up with a list of a ranking of 1 to 10 things that were important for this game. And Brad's just going to take you through them, and Rowan's going to explain why we chose scores.
Our most priority is strength.
We found that strength was the most important because when other robots are competing for the rings, we need our robot to be strong to get the stuff.
Our next is agility.
And what was the score, Brad?
8.
8. What I'm doing at the moment is adding those scores into what we call a decision matrix. And preloaded into the decision matrix are scores for each of the different drivetrains. So with us here, we have a, down the bottom you'll see there's a Mecanum drive. Really, really good, very agile, fast, Not so easy to program, not very good when it comes to pushing and shoving. Rowan here, can you hold it up this way, Rowan? This way so you can see the wheels. Rowan's holding a West Coast drive, centre wheels are dropped, much stronger, much more capable in the pushing and shoving, but lacks a bit of the agility and the speed. Caleb's got little belts. This was an omni-wheel hybrid that we created for Jeff's challenge. Its job was to be really small, fast and agile, so it's highly geared, very quick, very agile. But when it comes to competing against a bigger robot, obviously no use whatsoever. And a minute ago you saw Joey, which has what we call the H drive, drive wheels at the back, omni wheels at the front, and a tank drive is actually all solid wheels. So a tank drive is very hard to move, but also not the best at movement. So those scores are pretty to the table. And as Brad's giving me the scores for this game, we're adding a multiplier to the scores so that we can determine mathematically, not just with our gut, we want to make a Mecanum drive, which drive would actually work the best. So what are we up to, Brad?
10 for strength and agility 8.
Yep.
Next is speed, which is also 8.
8. Why do we need speed?
We need speed to quickly get the rings before the other robots do.
I mean, there's not a large number of rings in this challenge, and well, you know, we've got the few robots there, so we want to make sure that we're fast enough to get the rings before other people do.
And next would be drive, which is 5.
And what does drive mean? Do you remember?
The drive is like how the robot moves, like
How easy it is to train your drivers, because we know the best teams are those with the most experienced drivers. They're still rookies, they might not realise that, but they're getting there.
Next one is motors, which is also at 5.
And why did we think motors was pretty significant this year?
Because we only really need, or for our design, we didn't need a lot of motors, so we didn't need to put them on that much. So not that much.
We think there might be the need for lots of actuators in this game, because there's so many different components and so many different game pieces to manage that we may need our motors in other areas. So we felt it was probably important that we kept the drive motors to a minimum if we could.
Next one would be ease of build, which is at 3.
Now, this one will vary with your team's experience. For us as rookies, that's pretty important. For some of you, you might not care what you have to build because you can build all of them quite easily, so you might give that one a 0. But for us, we're still learning how to get things together. Putting together a good Mecanum drive might be a little bit hard for us. So if it's a hard thing to build, we wanted to scale that a little bit with ours.
The next one would be programming.
What's the score for that, Brad?
2.
2. And again, our programming team with our amazing mentor Sean are pretty good. They're actually probably more advanced than our build team, but your team might be the other way around, and you might want to rate how easy it is to program a drivetrain a little bit differently than we have. So when we put it all together, for our team, it's clearly showing the highest score there. We should be looking to build for ultimate goal, a West Coast Drive. Thank you for listening.
We are Team 10247, the Trinity Baconeers.
I will be sharing some tips and tricks on how to make a good engineering journal.
What content actually goes into the engineering journal? Well, any meetings you have, any CAD renditions you make, any maths or pseudocode or flowcharts or algorithms that you need for making your bot, any technical drawings or sketches of the bot or any mechanisms, any testing of the materials you did and your results, every one of your iterations of the design and the bot, and any of your ideas. Any planning and mind mapping of just anything about the bot, the components, ideas of what it could be, of how it could work, anything. In any important correspondence you have with other teams, like team members or fundraising, or any other outreach you do. You might want to have any budgeting in there, like fundraising and any goals you set for yourselves.
So it's really important to remember to not delay adding any information to your journal. Take notes as you go along every single time you have a session, and possibly have someone in charge for keeping track of the journal and the notes.
Some benefits of using an online journal include not being able to use it, better sustainability.
It's also like people if you can't meet physically, such as now during the pandemic, and everyone in your team has access to it so they can work from home, chances that they have internet. And any online meeting can work, such as HyperDocs, OneNote, Google Docs, Microsoft Online Word, and other digital platforms can help you build your journal.
For the day-to-day, you just need to say what you accomplished, how you did it, what you learnt, and what you need to do next time. Thanks for listening, and good luck in this year's season.
Hello and welcome back to the live segment. With me here I have Adam and Bailey, mentors of the Robo-Roos, who are going to be going through some of the electrical control system changes for this year. Just before we continue any further, there's some questions popping up on the YouTube live comment section Well, Adam's going to answer just a couple of them, and we're going to be having a Q&A session where we'll be answering more questions live if you have any for us.
All right, just on now is weight limit. The answer is officially no. There is no weight limit this year. You can make the robot as heavy as you like within reason, because if you damage the foot, then you're probably in trouble again. As a team that is noted for always pushing the boundaries of weight limits, I'm actually very nervous that I did this. But that said, we would hook up a phone to the expansion hub. All of the major processing is handled by the phone that's hooked up to that. Let's take it up. Is it? Good? Okay.
Everybody off the Wi-Fi.
No. I got like really good connection at home. Okay, we're back. Yep, hello everybody, we're back again apparently, so it's pretty exciting for us. Just want to go back to where we were because we're not quite sure on how much we'd lost that time around. So to start with, if you've done this before, the standard method is we use two phones. One phone is a driver station phone, one phone is the robot controller. The phone on a robot controller we hook up through a very fragile USB cable directly into the expansion hub, and then we do our controls from that. Out of the two, the phone which is that's used by the drivers is irrelevant. It doesn't have to be particularly powerful. We can get a relatively cheap legal phone and get away with it. The phone that is sitting on the robot though and is doing most of our processing is a problem. Are we still on? It's all being very entertaining technically.
Yes?
Okay, do we keep going though? Keep going? Okay. So what's changed this year is that we've removed one part from the equation. We now have access to a control hub, which Bailey is showing you. You do that very well. Have you ever seen Sale of the Century? No. No, we should teach you how to do proper Sale of the Century. You know, and that's it, perfect, that's it, we've got it now. Okay, so we now have a control hub. The control hub is effectively takes away the phone, puts a processor roughly equal to about a mid-level one of a legal phone. $US if you want to buy it through Rev. Plus you need to spend whatever it is that we have to pay for shipping hub, and we'll find it to be more stable. On top of that, the processor itself isn't too bad, but one of the nice things is that when we're using these phones as our control system, the thing is doing phone stuff. It's not just running our robot, it's also running all the phone things you'd expect a phone to be doing in the background. This takes it away. So the control hub is nothing but a dedicated controller for the robot. It's still running Android. We still program it the same way. We still treat it as if it's the same thing. But we know that the one job it's doing is going to be controlling our robot, and there won't be the stuff that could interrupt with it. Result is that teams are reporting that it's faster in its response rate than what we had with the phones, in particular for control.
go again.
Okay. Apparently we're back again, so we'll just try from, I think we stopped roughly when we were talking about the processor speed. So a couple of things we want to note about it. The first one is that if you've tried using a camera on one of these phones before when you were trying to do a vision system on your robot, it was possible, but you had to position the phone in such a way that the camera was still useful, which made it a little bit more complex, and we were limited to the camera on the phone. There were more options for teams that wanted to put in an external camera. If you were to do that, you would have to find a way of powering it because there wasn't enough power coming out of the phone to do it. So that meant we needed a powered hub and we had to hook things up and things were harder. What's changed with the control hub is it's a direct plug it into the USB port at the back. We can pick up any webcam that is more or less compatible with the software, which is pretty much every major one we can pick up. And then the flexibility of putting it anywhere on a robot we like is a really nice touch, and we don't have to worry about providing it any sort of special external power supply to get around that. So we should have an easier time for people doing vision systems this year. Certainly if you're using the control hub, the options for the cameras are good, and one of the things you can do is have the team test different cameras and different see about different resolutions and mess around and see what's going to work best for your particular setup. Otherwise, the control hub and the expansion port both can be connected to each other like they were before. The control port and the expansion hub have a number of different inputs, which hopefully Jessica will go through for us.
Hopefully. I'll get a little bit closer to the camera. So we still have the 4 motor ports over here. We've got power. You've got your lovely PWMs down the bottom over here. And along the side here is where you can plug all your sensors in. So you still have the 2 analog, 4 digital, and 4 I2C, so you get some more interesting sensors over there. Is there anything else notable about the inputs, Adam?
Not particularly. The main thing to keep in mind is that if you want to run more than 4 motors, you really would be looking at using a second expansion hub. You don't have to. You could use a Spark motor controller, which means that we can run it off the PWMs in order to control it, which is nice. But I tend to find that by the time I'm doing that, I'm going to start other things anyway, and the team's going to be saying that we basically want yet another servo added to our robot. Whereas such thing as too few servos on a robot, as far as we can tell. And so if we start sacrificing all of the PWMs for more motors, we're better off with a second hub. Generally speaking, having 2 hubs isn't a bad plan. Hooking them together is really easy. In fact, absolutely trivial. There's a little bit of software we need to go through, but not too bad. It's simply a matter of plugging in the cable into 2 ports and, yeah, we're done now. We have to share the power across as well, so we need to run a power cable between the 2.
So just like hooking up 2 control hubs, the 3-pin cable goes into the RS485 port.
Yep. Beyond that, what else we need to mention? We're going to mention that other than the performance being quite nice on both of them and everyone reporting it's good, they both have internal gyros, so that we don't need to worry about the phone gyro. If you wanted to go down that path, we still have access to one in the control hub, which is nice. Anything else that we particularly wanted to mention? I think we covered most of it. Yeah, so beyond that, I do like the new control hub. I think it's a better option. I don't think it's such a terrific option for teams that if you don't have one, you're going to be in a particularly bad position. I think it's better, but it's not better to the extent that you're going to suffer because you don't have it. But in the long term, I'd strongly be recommending that teams start looking at transitioning to the control hub, unless you're at a point where extra power on a higher end phone is really what you need, in which case you don't need to hear anything from us. You know what you're doing already, so it's not a problem at all. Okay, I think that's about it then. Thanks for that.
Thank you
and
very
hopefully
much.
the rest is a little bit smoother. I should add, it's nice having all these interruptions because it's exactly like competition with our robots, which constantly lose connections about every round. I think we managed to do last year, because of our problems with our phone connection, I think we managed about 1 out of every 3 rounds where we didn't hit connection problems. So,
And that's a very common FTC round for everybody, I think.
So dumping the phone from the equation is going to be a very nice thing if we can reduce that as a risk.
And just as a word of warning, remember to turn on your robots on the field.
That's worth mentioning actually. We now only have 1 battery to worry about. We have a phone charged and a thing charged, just the robot charged.
Pardon? And stop your robot at the end of the match. Thank you, Scott.
No problem. Thank you.
Thank you. Next up, we're going to have some tips from the Paladins on how to do some programming. So come on up, guys.
Okay, so what we're going to talk about here is what you can do while you wait for the build team to finish building the robots. We just saw all the real components there, but my experience has been over the last 4 or 5 years is that with teams, the programmers get the robot about 9 days before the competition, and sometimes still writing code on the morning of the competition. And so what we've discovered in the last couple of weeks, software called Virtual Robot. So you can get it on GitHub, and it's from Team 8397. It's called. So just search, GitHub Virtual Robot. You should be able to get it. Now, the instructions on there tell you that you have to use IntelliJ Community Edition. It does work in Android Studio, so you can use the same environment used to program the robot. And what it does is provides a virtual robot. Perhaps it's best if I go in and show you. So I'm just going to flip over to Android Studio. So this is the Android Studio. We might go full screen now. Yep. So if you have a look on the left here, so I'm in Android Studio, and we can see there's a controller project. Team code is where you go, just like you do normally with Android Studio with the FTC SDK, but it's not the actual FTC SDK. It's pretending to be the robot. So we can't do everything, but we can do motors, we can do sensors. It has an IMU. And I'll just run it just to show you what you can do. And I'll get Caleb here to run the controller.
Sure.
Right, so you see I've loaded up the new gamepad and the field already. So I'll just, it's just like on the real robot, you have to select the robot configuration. And so I'm going to choose the 2-wheel bot, which is there. And you have to choose your op mode. Which one are we going to go? Okay, I think that's the one we want. So, and just like on the robot controller, you press and start. You'll have to go start A to name of the gamepad, and now you can drive it around. Now, which one is that on? That's on that one. So, the sorts of things you can do in this is actually really. So, when you're running a real robot, there's sort of systematic errors that creep in. The robot doesn't always drive straight. So we can actually add in random errors and systematic errors and motor inertia so that it adds, so that it operates a bit more like a real robot.
So right now I'm pushing the controls to go straight forward. I'm not giving any turning at all. And you can also print a line of the path it's taken, and you can see it's not a straight line, even though I have been driving the robot in a straight direction. As we know from real life, they don't go straight. And so this is actually a really good opportunity for potentially looking into programming your gyros or any other ways of keeping it going in the right direction.
Right, Bryce, you want to just minimise again? I'll just one of the things we can do is if you don't, so we've just used a standard, I can't see now, yeah, just a standard gamepad that we use in competition, just plug straight into the laptop. But if you're at home and you don't have your own controller, we can actually put on a virtual control pad. So I'll just quickly do that, show you what that looks like. So what I'm doing here is I'm going to change the config to say use a virtual gamepad. And when I rerun it, we can see now it's got a little bit of a gamepad at the bottom. So This is actually really useful for just trying stuff out, even if you don't have the gamepad.
I think this is really cool because if you're a new team and you're at the point where you don't have anything, but you've got a few programmers or a programmer that's interested in actually starting to figure out how to do some of the programming, you don't need anything. You don't even need the game controller. You simply need Android Studio or IntelliJ on your computer and just download the virtual robot off of GitHub. And I mean, obviously alongside some other learning resources, it's a great place to practice without anything.
Yep. So I'll just put up that web page again so you can see where it's from. So it's beta 8397. If you just search for GitHub virtual_robot, you should be able to find it. The only thing I'll mention is that to use it in Android Studio, you will have to specify a JDK that includes JavaFX, and you can search online for those. Right, that's it from us.
Awesome.
I'm ready. Is it on? Okay. I still can't see it on screen. There we go. That's pretty small. I'm Sue O'Malley again from the panel. I'm just here to talk to the coaches, actually, of teams across Australia. And just to remind you that there are massive amounts of resources available on the FIRST website. And that's the firstinspired.org website from the United States. Copies of the game manuals, coaches information, examples and exemplars of notebooks especially are really useful. You've got assembly instructions for a do-it-yourself field. If you haven't got access to a field or it's just simply too expensive to get one, they've got instructions on how to build them out of cardboard boxes to give you the best possible chance of being able to compete successfully. There's all sorts of swag there with stickers and logos and things like that that you can download as well. The forum questions that we've mentioned a few times today to keep track of the rule changes and clarifications, the link is there as well. And things like examples and help for using computer vision and ideas of where to go when you're stuck. The other thing that's really great is there are some fantastic Facebook groups out there. FTC Share and Learn is particularly wonderful. The Session Brothers, Asher has connected up to that, and it's a great place to go when you're stuck. If you don't know exactly what you need to do next, jump into these groups and get the wisdom of ages from the coaches that have been around for a long time. And of course, if you need any help, you can contact any of the teams that were here presenting today. We really enjoy supporting and helping everyone around. So that's the Robo-Roos, the Paladins, the Baconeers are great, always good, the Bunyips and their bunch of bots. Thank you.
Okay, so we're probably going to have about 20 minutes, see how we go, of question time that you can be asking questions on the live stream with the YouTube, which Cara lovely has here, ready to ask questions. So, fire away. Does anyone here presently have any questions or statements that we can address? Any questions?
There's no questions in the live yet, so. Yeah, it's all good.
Typing faster.
You know, one thing that I thought was interesting was the wobble goals. And how at the end of the thing you don't throw them, you place them out of the field. And I was thinking, maybe you could take both of them. But it's actually written in the rules that you can only control one wobble goal, if anyone's thinking of that for strategy.
Only control one wobble goal on the way out.
You can actually only control one at any point in time. So that's interesting.
So you'd have to make 2 runs if you wanted to move it again.
Yeah.
So the only elements we have are the discs. Now, what are those discs made of again?
Foam. They weigh about 30 grams each. And based off some testing that some teams in the US have done, you can squeeze them by about ½ an inch, just with your hands.
So that's an important little note to make when you're trying to work out your tolerances.
So we've got our first question in the chat. Is there any rules saying how you have to drive? For example, tank drive. So are there any rules about that?
No. There's no rules about how you have to drive, as long as it's following the rules of being controlled by your phone and controller to the robot.
I think with that, one thing to think about, a few presentations ago we had the drivetrain one and you saw how many different ways there are. You've got to keep in mind each different sort of driving method has its own controls, and you definitely want to spend quite a lot of time thinking about, what joint mappings you want, how you want to write code in autonomous. I think that's a decision that needs to be made with the operator, or at least for the control one, with the programming team, and also obviously the build team.
The other thing to note with drivetrains and what you're choosing is make sure you're not damaging the field in any way. So if for some reason you've got some really super sticky tires that are gonna mark the field, then that's not really okay.
And no sharp, low-hanging things. Yeah. And if you get stuck and are potentially going to damage the field, Robo-Roos, don't keep driving.
Yep.
So yeah. Awesome. Good notes. Also note, make sure you have your numbers big on display. It's a common failing point when you rock up a competition. Another common failing point when you rock up a competition is you don't have your alliance markers, very important, as well as the warning labels that tell you that your robot will move when it's started, and that that's where the power button is. Make sure you clearly label and make sure your power button is accessible. Also turn your robot on when you enter the field.
I think the thing about the power button is really interesting. It does need to be accessible, but try and make it in a place where it's going to be hit, and because if that power switch gets shut off, you're done.
Yeah, you cannot reach into the field and turn the robot on again. Oh, there's a question in the audience. Technical difficulties plague today.
They do, but that's all right. We get it.
Yes, we've got a question for you. How many rings can you shoot at once?
So to repeat the question, how many rings can you shoot at once? What's the answer to that one?
You can only carry 3 at a time.
Yeah.
But apparently you can only shoot 1 at once.
Yeah. You can only launch 1 at a time, but you may be carrying 3.
Yeah, you can be in possession of 3 rings. Now keep in mind that includes if you're shoving them along the floor. You can run into something or knock it just accidentally on your way through, but if you're controlling where the ring goes, it counts as being in your possession.
Also note, if it is accidentally stuck on a tower, say on your robot, it's fallen on top of it. If your robot's got it, even if you can't get rid of it, it is in your possession. So don't go grabbing another 3. You can only control 2 from that point on.
So to be really specific, when we say in possession, which is the 3, that means making contact with the robot, physical contact.
Yeah, and is in your control. Transient, I'm moving through them because they're lying on the floor, doesn't count.
Okay.
But if you've got it and you're pushing it, if you're transient and you're now pushing it in a directional line, that's in control.
All right.
Okay, that's good. Wow, you're so quiet.
Yeah, I know. It's not very many questions.
I suppose everything's been made so clear.
Oh, is that a question in the field?
I haven't read the campaign yet. I was wondering when the human player returned the ring to the return back, a robot picked up the ring.
So my understanding of the rings being returned to the field is that the robot can pick them up as long as it doesn't leave the field. I'm not certain how far away the thing is from the edge of the field, so as long as the ring's within the field, the robot can pick it up. Whether it's catching it mid-air or whether it's on the floor, I don't believe there's an issue. Oh, it does have to hit the floor? Alright, never mind. So it has to hit the floor and then you can pick it up.
So it goes through the little channel, and then once it hits the floor, it's free for the robot to pick up. So you can't pull a trick like sit underneath the loading thing and load it straight into the robot. It will be a picking up off the floor game.
Yeah.
We had information earlier as well that human players must return them to the field as soon as possible. There's a slight grace period, much, so they can't strategically wait until the right robot arrives and then drop it on the field.
So yeah, must be returned straight away to the field, and then that makes it a free-for-all kind of game.
That grace period is 10 seconds, correct?
Yeah, it's very short, very short. If you look like you're doing something strategic, you'll be told off.
Don't play any games, just...
Yep. And the same goes for resetting the power
Pulse?
Shots?
Power shots. Some interestingly named elements this year.
Yeah, it's going to be interesting.
It's going to be a very fast-paced game. I feel sorry for our scorers who are going to be having to score what goals they're going through as quickly as it happens. And yes, blocking them coming at their own faces potentially.
That's another interesting thing. When you're shooting and launching your discs, your rings, you can't intentionally launch them outside the field. However, there is a rule within the manual that says if it is deemed to be completely accidental by the referee, you won't receive penalties. But keep in mind, it is not a good strategy to be like, oh, it was an accident, because they will know if it's not an accident. But if you genuinely accidentally aim a little bit too high and it goes over the top of the goals, you'll be okay.
Try and keep your aiming systems quite simple and reliable. I'm predicting there'll be some interesting autonomous shots made.
Yeah. Questions open? Yep. So we've got a question which is, do you have to finish the robot where you started, or can you just stop anywhere on the field?
Is this an autonomous, I would assume?
So there aren't any rules against stopping anywhere. However, you get points depending on if you're stopping parked on the lines or depending on which game period it is.
And so you'll have your robot stop at the end of autonomous, basically based on what task it's completing. If you're moving the wobble goal, or if you're trying to launch from a certain part to knock down the power poles and get those extra points. And then in endgame, there's also extra points where they can get more places to be. I think there's another question over there.
Yeah.
So in the end game, there's the zones marked out in the manual where that they can get more points, I think. Yep.
So how many rings can the wobble goal hold? And if you're controlling the wobble goal, are you going to be penalised for carrying more than 3 rings?
Are you only allowed to place rings on the wobble goal in the last bit, and you place them earlier as well?
There's nothing nothing against you placing them at any point during the game. However, they're only scored if they're on that line at the end of the game. I double-checked the rule, but I remember reading a rule that said you could, anything that's fully supported by the wobble goal doesn't count as being in your possession if you're moving the wobble goal. So you could pile up as many rings as you want, like 5 rings, push it onto there, and then that's 30 points at the end game if you line it up on the line. So that all comes down to strategy, I think. Yeah.
Again, I don't know. That seems like it's the really common thread. But I mean, I'm sure with past first competitions, but I think with this ultimate goal in particular, I think there's so many ways, so many creative ways as well of going about the competition. And there's ways that other teams will think of that I'd have no idea about. And I'm sure when we go to the game, there's going to be many surprises, absolutely many surprises of what, you never know what could happen.
So we've got another question here on the discussion.
It says here, robots are not allowed to place rings onto wobble goals except during the end game.
It is in the end game, but you can do it anywhere on the field. Yeah.
So the wobble goal can take 12 rings, and you may only place those 12 rings on in the end game period, which is the last 30 seconds, 15 seconds?
30 seconds, I believe.
30 seconds. The last end game, which will be signified to you. And
yep. So there's another question that we've got in the chat, which is if you put the wobble goal outside the field, are you allowed to touch it? For instance, if it falls over, can you put it upright? Because it is outside the field, if your robot were to reach out of the field and move it, then that'd be considered exiting the field, which you're not allowed to do except when placing that outside the field. And correct me if I'm wrong, but I don't believe there's anything that the thing can't be knocked over when you put it in the drop zone, as long as it's in the drop zone. And no human is allowed to touch it outside the field either, because you have to be contained to the station areas.
So yeah, don't put robots where people are.
Yeah.
It's
Yeah,
over the fence, over the start, in front of like the starting.
Yeah.
So you've got to watch out for that. So we'll have to keep people away from those at your events.
Yeah. Don't want to get hit by any robots.
Yeah, a lot of things are being launched. You may need to invest in protective eyewear.
Yeah, got to be wearing your safety
Protective
glasses.
eyewear is a must.
Yeah.
Enough questions yet? Or are there more questions? Oh, there's another question.
There's another question.
You've got
What defines out of the arena? The arena is specified to be like, so it's 6 feet and then 6 feet up. 12 feet. 12 feet, sorry. 12 feet, 12 feet, and then 12 feet up. It's a cube, although you're not really going to make it to the top. It's just a plane at the edge, and if you're outside of that, then you're considered outside of the field. However, if your robot is like a teensy tiny bit out and it's completely accidental, again, it's not going to be considered a foul. It's only if you're intending harm or could cause harm by like accidentally leaving the field or intentionally leaving the
if
field.
you stick your robot out and you hit somebody,
Yep, you're going to get penalised.
You're going to get penalised.
Yeah. So we had something asking.
You want the questions?
Yep, the questions are here. So we've got someone who would like to know how much the wobble goal weighs. Can we put the, and then we've got one that says, can we put the wobble goal outside the field even if it has rings on it?
Yes.
Yeah.
So the wobble goal can go outside if it's got rings on it into the drop zone. And then how much does the wobble goal weigh?
Wobble goal?
I don't know. Rob says he doesn't know.
We can check that.
Check it up in the rules. Kilo? About half a kilo, says Steve.
So the other question that we've got here is what's the penalty if you step outside of the human player station?
That's a good question. Yeah, it's
Yeah.
usually a minor, then a major foul. So
those fouls will accumulate against you, and they give points to the other team.
Yep.
Yeah, if you're doing it strategically to, say, duck around and have a look and then tell your team something, that'll escalate quite quickly, and then you can get a red or a yellow card.
Yep.
Probably get a warning first.
Well, yes, you'll get a warning first. Keep your toes inside the line, and then if you keep doing it, you'll get more fines.
So we've got a couple of questions about how much the wobble goal and how much the rings weigh. And based off of internet discussion, because obviously we don't have the field here yet, the rings weigh about 30 grams, and the wobble goal weighs about 0.9 pounds, which I think is about half a kilo in kilos.
About half a kilo.
About half a kilo, 500 grams-ish. Yeah, 0.9 pounds.
Excellent.
Yeah. So that's all the questions I can see in the chat. Anyone got more chats here?
It's 400 grams.
400 grams?
So
Yep.
just a little bit less than half a kilo. We'll be getting a field in soon.
Yep.
And then that way we can hold another live stream that we can then discuss about the remote rules, and also discuss for teams in Australia particularly about what the field elements look like and how they interact with the field. But there are some good ones up already from America where they already have access to the field. But if you want to ask us more questions about it because you don't have access to a field, we'll be able to get that information to you out soon with all the stuff here for you. Yep. And we'll personally weigh them to make sure that they're right.
We've got a question. What happens if the controller disconnects? And this is one from my team's personal experience. Is a bit annoying because there's no rule that says that the game has to stop or anything. It's got to do with so if you can get your controller to reconnect by fiddling around with your phone that you've got in the driver station, then that's all fine. But if it's something on your robot and you can't get it to connect, it's just going to have to stay where it is.
Even if you can see the problem, the wires come unplugged and the robot's sitting right there in front of you, you cannot reach your hand in and fix it. Yes, Scott?
Just to add to that, if it is determined to be an arena fault, so there's a fault with the field or something outside of the team's control, then that may be grounds for a match replay. But other than that, if it's something that you could have fixed on your robot and it doesn't affect other teams, then you're not going to be able to replay that match.
Yeah, so if it's something that it was the arena's fault that caused your problems, and it caused problems for pretty much everybody, then you may get a match replay, but that's very, very rare. So if you'll normally get an FTA come and try and help you, they'll try and sort it out. They're very friendly, they'll try and fix it because they want to see you play, but sometimes it just can't be helped, so you just gotta stiff up a lip and wait for the next match.
Alright, we got another question. What happens if the robot falls over near the edge and you can reach it and quickly tip it back up?
You cannot touch the robot.
No touching the robot.
No touching the robot while it's on. No touch.
If another robot from your alliance can knock you and fix you, then that's a different story. They can turn you right back up, but
so if you get knocked
no
over
people can
and they get
touch
you.
the field.
And the ultimate GP is helping the other alliance get back on their feet. That happens a lot.
Gracious professionalism.
Woo!
Help the other alliances if you have time, but they're normally pretty time-pressured games.
Actually, I love the whole idea of the alliances, having two robots from two teams that you don't know who you're going to get, and just being put to work with each other and help each other out. I think that's a great thing, and it's one of the things that First does, which I really love.
Love really well. More questions?
No, we don't have any more questions.
No more questions. Ooh.
Is it about time to wrap up this stream?
I guess so, unless we've got any more questions in the house.
Nah, I think everybody's pretty ready and excited.
Oh, there's a question.
Oh no, that's just
no,
saying
that's-
goodbye.
What, is that a question?
Is that a question?
Oh,
That
so
is a question.
We've got a question.
Will it hurt if you get hit by one of the rings?
Will it hurt if you get hit by one of the
The
rings?
foam.
Let's test.
Probably in your
Well,
eyes.
we can't.
Maybe we can test that on the next live stream.
And we've got the test subject right back there as well.
Yeah, but safety glasses and try and avoid getting hit by one of the rings.
Don't throw rings at people.
Don't throw rings at people on purpose.
Yeah.
I can just feel Autonomous might have a different goal than
Yeah.
us.
Lots of funny stories about robots going the exact opposite way to the way they're supposed to go. You put in the wrong program, or it sensed a colour off in the distance and it just goes the wrong way.
Awesome. Well, that's all the questions that we've got. So do we want to wrap up?
Yeah, I think that's it.
Oh, we've got a quick question.
One more
Is there a
question.
penalty for hitting a person? Yes. If it's intentional, yes.
If you're intentionally trying to hit the referees so that they can't mark your scores, yes, you will be penalised. You'll get major penalties and then red cards very quickly.
Whether it's intentional or not will depend on whether it's a minor penalty or a major penalty. So that's all up to the discretion of the referees.
And the referees' decisions are final. And so you want to be nice to your head refs, and no video evidence. If you can't, even if you can prove with 100% certainty that you didn't do it on purpose, once the game's over and it's been played, there's no point. Come back to it. Just come back and play the next round.
Yep. So we've also got one that's, how often can you reload the rings back into the field?
You have to reload the rings immediately as they're being shot into the goals. So one comes in, you put it back out.
Yep. And someone just wanted clarification. Yes, the rings are made out of foam.
Yes, foam.
We haven't held any of the rings yet ourselves, so we can't tell you too much about them, but based off of what we've seen online, it's a pretty dense foam, and it can bend, but it's fairly dense and firm. And we've also got, if a ring goes outside the field, can it be put back into the field? The answer is no.
It would be
based
it would
off
be
of
put
where
back
it is.
It would be put back into play potentially by the referees, not by students.
By the human player, I would expect.
Yeah. So, but that's up to your referee's discretion.
Yeah.
All right, so no more questions? No more questions
No
from
more
the live
questions.
audience? Awesome,
I think
okay.
that's good. What
question?
Scott?
We're good?
We're good? We're good.
Awesome.
So, I think this has been a pretty great kickoff event. What do you guys think?
Without a doubt. Absolutely. I think just having everybody, first off, everyone in the room, being here, so many great people interested, you know, in the FIRST community, it's great to have everyone under one roof. And I also would like to put a big thank you out to, firstly, everyone that's watching the live stream, but then we also need to give a big thank you to the amazing people who have volunteered to help us run the live stream.
So a big thank you to Bryce, Scott, Rob, Sue, pardon? Macquarie University.
Yeah, obviously.
And Luann and Sue and all of the other mentors that came out here today to make it possible, all the students, all the parents, everybody who's here, all the alumni.
Our tech wizards.
The tech wizards. None of this is possible without everybody's support and cooperation. So big thank you to everybody, and I hope to see you all in November when competitions start, and maybe on some more live streams